All right. Good morning, ladies and gentlemen. We are going to go through how to find all the complex roots of this fifth degree polynomial. Okay. There'll be two other videos put out there by other teachers, three different levels. The three different levels have three different processes of solving for the last two remaining roots at the end of the process. So anyway, with this one, let's get going. Ultimately, we're going to have to graph this function to be able to get us going. But there are a few things that we can do prior to looking at a graph. Our end behaviors, we can determine that just from our equation without having to look at a graph. We'll verify when we get to the graph, but we don't need it at this point. So what we're looking at is our leading term. Okay. And so by looking at the exponent or the degree, that's how we can determine if it is even or odd. So here we have x to the fifth. That exponent is odd. So how did I know that? Look at the exponent of the leading term when it is in standard form, going from largest degree to smallest degree. Then I look to see this is a positive function. I can tell again by looking at the coefficient of the leading term. And the coefficient is 1. Okay. So from that, we can describe our end behaviors. So I always ask my students to do a little sketch. If it is a positive function, I know the right end behavior is always going to be going up. And because this is odd, that means that my left end behavior is going down. So from that, we can break this into its pieces. So as x is going off to positive infinity, my values of y are going off to positive infinity. So my right end behavior is as x approaches infinity, y approaches infinity. Now, my left end behavior as x approaches as x approaches negative infinity, y approaches negative infinity, it goes down. So as x approaches negative infinity, or it gets infinitely small, y approaches negative infinity. I think the little sketch at least helps, from what I've seen my students have an understanding of that. So there's some information that we can get prior to having to graph it. But we're going to graph it anyway, and we'll verify that that's accurate. So next thing, all right, we're going to graph. And so I'll just recopy my equation. All right. Oh, I've already entered this in, so I don't have to take that time. Now, when you get a graph, you're probably going to have to make some adjustments. Here it just looks like I have a vertical line and a parabola. Okay. But what I really have is I have a polynomial function. I just can't see all of it right now. We don't necessarily want to change our x-axis. That can stay the way that it is. All right, but I do want to change my y, possibly my y maximum. So I'm going to go to this little wrench in the upper corner. And on my y-axis, I'm okay with my y min, but I do need to change my y maximum. And so I'm not exactly sure how high up to go, so I'm just going to kind of play around with some values. Although I do know my y-intercept is 468. So that's probably an indication that more along the lines, even, well beyond 500, beyond 1,000. Let's go up to maybe 1750. All right. And then we can establish our graph. And I'll just move it just slightly so that I can see where my x-intercepts are. Okay. So one thing they wanted here was for us to capture a picture of this and put it in to the document. Okay, so I'm going to capture my picture, try and find this. Let's see if I can't. Not exactly sure how to insert a document into a Cami document. Oh, maybe over here. Add media. All right, I want to add from my computer. I did a screenshot, so I should be adding this. All right. And there it is. All right. So next thing I need to do is I need to identify my x-intercepts if I can from the graph. All right. So as I do that, I have an x-intercept here. I also have an x-intercept there. So I have x-intercept at the point -4, 0. I also have an x-intercept at the point 3, 0. Now, if we take a look, if we recall what we talked about the other day, it comes down, it touches the x-axis, and then it changes directions right away. It bounces, okay? So that means it has a multiplicity of 2 or a double root. So it actually occurs twice. So what are my roots? The roots that I have -4. That is a single root. It crosses the x-axis here. I also have 3, and that is a double root. It bounces at 3. So I have a total of 5 solutions that I'm looking for. Okay, 5 roots because it's a 5th degree. I know 3 of them. Okay. So use the x-intercepts to write the factored form of the equation. All right. Well, so what I've got at this point, whoa, there, where did it go? Where did it go? So at this point, I have, if it's x -4, the factor is x + 4. And if it's x + 3, I get x - 3 squared. So that's what I have so far. Okay. But I'm also missing two more factors because it's a 5th degree and I only have 3. So what I'm going to do is I'm going to do some division. Now there's multiple ways that I can go about this, but I'm going to choose to use synthetic division. Okay. So recall here that I have x to the fifth minus 8x to the fourth plus 10x to the third plus 100x squared minus 411x, and then plus 468. And I'm going to divide that, all right? I know that I have, my roots are x plus 4, x minus 3, and x minus 3. So I could divide that by any of these, and I'm actually going to divide it by all of them. And I'm going to do this in a by doing repeated synthetic division. Okay. So it doesn't matter which term we start off with. I'll just start off with -4. Okay. So if x plus 4 is my factor, I want the root. And so now I take the coefficients from my equation. 1, -8, 10, 100, -411, and 468. So I'm going to bring this down, and then I multiply. And then I add, and then I multiply. And then I add, and multiply, so -232. We multiply. We add, or in this case, we subtract 411. And then we multiply that by -4. And we get -468. We add, we get 0. Okay? So that's key. We need to get 0 at the end. If we don't, that means it's not a factor. More than likely, we did some arithmetic wrong. So just be aware of that. So I'm just going to use my new expression here. I've gone from a 5th degree. This is now a 4th degree. And I'm going to use one of these two. So now I'm going to use, if those are my roots, those are my factors, I'm going to use a root of 3. Then I repeat the process. 1, multiply. Add, multiply. So we add, and then we multiply. And then we add, and we multiply, and we get -117. Good. And when we add that down, we get 0, and that's what we need. Okay. I have another root here, sorry, another factor, so that means I'm going to use synthetic division one more time. The ultimate goal is to get down to a quadratic. So I bring it down, I multiply. I add, I multiply, and then I add. And then I multiply. And again, I get down to 0. Good. So what have I done? I started with a 5th degree function. All right. So my 5th degree function, x to the 5th minus 8x to the 4th plus 10x cubed plus 100x squared minus 411x. And I'm going to run out of room. Plus 468. Then what happens is I factored this out, and that brought me down to fourth degree polynomial. X to the fourth minus 12x to the third plus 58x squared minus 132x plus 117. Then I factored out a 3. Okay. And then it brings me down to x cubed minus 9x squared plus 31x minus 39. So I'm down to a cubic. And then I factor out my other 3. And now I'm down here, x squared minus 6x plus 13. I'm down to a quadratic. And now we have quadratic formula or factoring that we could use. Okay. So I'm going to do a quick check to see, is there anything that multiplies to be 13, adds to be negative 6? Nothing that I'm aware of, nothing off the top of my head. So it looks like I'm going to have to use quadratic formula. So I'm going to identify my value of A as 1, B is negative 6, C is 13. I'm going to use the quadratic formula. X is equal to the opposite of B. So the opposite of negative 6 plus or minus B squared minus 4 times A times C all over 2A. Okay. I don't have a ton of room. So let's, if we simplify this, we get 6 plus or minus. So we're going to have 36 So we're going to have here the square root of negative 16 all over 2. So x is equal to 6 plus or minus. So square root of 16, that's the same thing as the square root of negative 1 times the square root of 16. So plus or minus 4i over 2. And then this simplifies. 6 divided by 2 is 3. 4 divided by 2 is 2. So those are my last two remaining roots. So ultimately my roots are, come on, x is equal to negative 4, 3, 3 plus 2i, and 3 minus 2i. And there you have it, ladies and gentlemen. I know it's a lot. It's a big process. But break it into small pieces. You can do it. It's very manageable. So thank you for your time. Appreciate it.